you type SSH app01, expect a shell, and get permission denied, public key. The key is on your laptop. You can see it. Maybe you even pasted the public key into authorized keys twice. Stop editing random files. The first question is not, is SSH broken? The first question is, which account did the server think you were trying to log into? Most public key failures are ordinary: wrong username, wrong key offered, permissions rejected, ownership wrong, server policy says no, or SELinux labels do not match. Permission denied. Public key means authentication reached the public key method, but the server did not accept a key for that target account. It does not prove the key is missing. It does not prove the network is down. It does not even prove the server saw the key you intended. OpenSSH is intentionally strict here. A private key that is readable by other users is ignored on the client. An authorized keys file in a writable home directory can be ignored on the server. If password authentication is disabled, there is no second chance. The message is short because the server avoids leaking detail to unauthenticated clients. Walk it in order. First, username. If you connect as Ubuntu but the key is installed under EC2 user, the right key is useless. Second, identity selection. Your agent may hold 5 keys, but IdentitiesOnly yes tells SSH to offer only the configured IdentityFile entries. If that file is wrong, the correct agent key stays on the bench. Third, permissions and ownership. Client private key should be 600, and the client.ssh directory 700. On the server, the user home.ssh and authorized keys must pass strict modes checks. Fourth, SSH config may block root, password fallback, or public key off. Fifth, SELinux can deny a perfectly named file with the wrong context. Here is the client-side pass. The first command runs SSH with verbose debugging and names one private key. In the output, look for offering public key and server accepts key. If you never see the intended key offered, you have a selection problem before the server ever checks authorized keys. In SSH config, IdentitiesOnly yes is useful for predictability, but it must match the IdentityFile line. If IdentityFile points at the wrong key, SSH will not rescue you by trying every agent key. The chmod line set the standard client permissions, directory 700, private key 600. To open, and OpenSSH may ignore the key to protect you. A common real ticket. New admin account, public key pasted correctly, login still fails. The debug output shows the key offered and rejected. On the server console, set a variable for the user home so the commands are harder to mistype. The home directory must be owned by that user and not writable by group or others. Then .ssh should be 700, and authorized keys should be 600. Also check the public key as one complete line with no wrapping damage. After fixing this, watch the server log while connecting again. On many systems, that is journalctl for SSHD. Debian style names may show SSH instead. Permissions are not the whole story. Ownership matters. If root created /home/user.ssh and left it owned by root, the login may fail even though the numeric modes look perfect. Recursively chown the .ssh directory to the account. For the home directory itself, ownership should usually be user.user, and it must not be group or world writable. On SELinux systems, copied home directories often carry the wrong label. RestoreCon puts the default context back, commonly sshhome.t, for SSH files under home directories. Strict modes yes is the normal secure default. Turning it off hides bad administration and weakens protection against tampered login files. This error connects several SSH topics. Client configuration decides which username and key are attempted. Server configuration decides which authentication methods exist. Permit root login no, blocks root entirely. Prohibit password allows root with keys but not passwords. Password authentication no is normal on hardened servers, but it means a failed key ends at public key with no password prompt. Pub key authentication yes must be enabled for keys to work. Authorized keys file tells SSHD where to look, normally .ssh authorized keys relative to the user home. Later in the series, logging, match blocks, certificates, and bastion hosts all build on this same decision path. Practice on a VM you control. Create or use a non-root account with key login working. First, connect with the wrong username and observe that the same key fails. Second, add IdentitiesOnly yes with an identity file that points to a different key. Then run verbose SSH and confirm the intended key is never offered. Third, restore that and change authorized keys to mode 666. Try again, then put it back to 600. If your VM uses SELinux, copy the .ssh directory from somewhere else and run restorecon afterward. The point is to learn the order, not to memorize guesses. 3 beats to keep. 1. Check the username before touching files. Wrong account is the fastest path to public key failure. 2. Verify the key actually offered. Then fix 700 and 600 permissions on both ends, including home ownership. 3. If files look right, check SSHD policy and SELinux context. Do not disable security checks to make the message go away. Fix the reason they complained. This is SSH Mastery, one SSH administration and defense topic every day, from zero to expert. Also watch the daily ranked CVE brief for what matters in current vulnerabilities.